Right, I'm going to do some exam questions about making ions and ionic bonding. So the information in the box is what you need to learn and know, and then we can use that to apply it to the questions. So metals always form positive ions because they lose electrons to have full outer shells. Okay, so they've got spare ones in their outer shell and they will give them away in order to be stable. Non-metals will form negative ions because they gain electrons to have full outer shells. Now, once we've got our two different types of ions, once we've got our positive and our negative, those opposite charges attract one another. Okay, and that's called electrostatic attraction. Now, that attraction is very, very strong and takes a lot of energy to break. So once we've formed an ionic bond, and particularly the large ionic compounds, those need a lot of energy to actually try and break apart those bonds. So ionic compounds have got very, very high melting and boiling points. Now, in an ionic compound, the ions are held really, really strongly in place. They can't move when they're solid. So ionic compounds can't conduct electricity when they're solid. Now, if I dissolve an ionic solid, or I melt it, then the ions are able to separate and move. And because they can move, then they can flow, and that will allow them to conduct electricity. So they can't conduct when they're solid, but if we melt them or dissolve them in water, then they are able to conduct. Okay, so like we've done before in the videos, you can pause it and have a go at the questions, see how you get on, and then when you come back, I'll go through them. So the first one, sodium reacts with chlorine to produce sodium chloride. Balance the equation for the reaction. Now, if you are not sure about balancing equations and there is a space, always put a number 2 in it. Okay, if you are completely unsure of how to balance equations, always put 2s, right? Because you're better off giving it a go and guessing than leaving it blank. Now, I've got sodium here. There's only one sodium, and it's joined with chlorine gas. Now, chlorine gas likes to hang around in a pair, so that's Cl2, and it makes sodium chloride. Now, the problem I've got here is that I've only got one chlorine. Okay, now I can't make that into a 2 because that would change my chemical, would change my compound. So what I'm going to have to do is put a 2 in front of that. Now that 2 times everything by 2. So now I've got 2 chlorines, that's perfect. The problem is I've also got 2 sodiums. Okay, so I need to balance it back on this side by putting another 2. Now that is the most likely number that you are going to come across. So if you don't know it, okay, have a guess and put 2s on the line. Now, the diagram below shows part of the structure of sodium chloride. Now, you'll notice that there's charges on all of these ions, on all of these circles, okay? What holds the particles together in sodium chloride? So because they're opposite charges, then it's going to be the electrostatic attraction. Okay, so opposite charges are attracted electrostatically. Just move those out of the way. Right, so solid sodium chloride does not conduct electricity. Give 2 ways in which sodium chloride can be made to conduct electricity. So we can dissolve it in water, or we can melt it. Okay, so that's our 2 ways. Now, next question. Again, pause the video if you want to so that you can go and have a go at it yourself. So a sodium atom and a fluorine atom react together to form an ionic compound. Figure 1 shows the electron arrangements in the atoms and the ionic compound. Okay, so these are the atoms. Only the outer shells are shown. Okay, so that's why this has got 1, because sodium is in group 1. Okay, fluorine is in group 7, so it's got 7 electrons on the outside. Now they've used a dot for this one and a cross for this one. They're both showing electrons, but it's just so that I know which is which. Okay, now because sodium has got that 1 electron there, okay, it's easier to lose 1 than gain 7 to have full shells. So it's going to lose that electron. So I'm not going to put, there's no dot on this ion. Okay, now if you notice, that dot has been given to the fluoride. Right, so this sodium is now a plus because it's lost an electron. The fluoride is a minus because it's gained an electron. Okay, what's the name of this compound? So we always change the name of the non-metal, right? And it will be sodium fluoride. Okay, what type of force acts between the ions? So again, it's opposite charges, so it will be electrostatic. Okay, now this is one that you need to be able to do. So pause the video, have a little go. So describe what happens when a sodium atom reacts with a fluorine atom to form an ionic compound. There's 4 marks for this. Okay, so we need to say, what does the sodium do? What does the fluorine do? And how is it held together? So this diagram actually helps us. All right, so there's lots of clues in questions if we actually look at the information. So sodium loses 1 electron to form a 1+ ion. Okay, then I'm going to describe what happens to the fluorine. So fluorine gains 1 electron to form a 1- ion. Right, so the oppositely charged ions are attracted to each other in all directions to form ionic bonds. Okay, so that's your 4 marks. Now, although this is about sodium fluoride again, it's actually a different question. Okay, so again, use what we've just done, pause the video and see if you can have a go at it. So, right, so first of all, an atom of sodium and an atom of fluorine react to form a sodium ion and a fluoride ion. Complete the dot and cross diagram for sodium ion and the fluoride ion. Show the charges on the ion. So basically, they've given us half the information that they gave us before. So that is going to go over here. So I'm going to have X, 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 X. So that's the 7 electrons from my fluorine plus the 1 from the sodium. That becomes a plus ion. That becomes a minus ion. And this picture is exactly the same as the one that they gave us before. Okay, so they will use, you need to be familiar with these sorts of pictures. They will come up quite frequently. Now, okay, describe how sodium and fluoride ions are held together in sodium fluoride. So this comes exactly the same. Oppositely charged ions are attracted to each other in all directions. Okay, now if you want to say this is electrostatic attraction, oops, I'm going to fit it in on the end. Okay, so some of these questions, it is just a prescribed answer. We just need to get used to recognizing that prescribed answer. Right, so the next one is about sodium chloride, but it follows exactly the same pattern. Okay, so sodium is in group 1, chlorine is in group 7. Okay, describe what happens when a sodium atom reacts with a chlorine atom. So it's going to follow exactly the same pattern. Sodium loses 1 electron to become +1 ion. Chlorine gains 1 electron to become -1 ion. Now, if you look what I'm writing here, There's the one that we did before. Oh, I've lost it. Okay, I'm going to write exactly the same idea. The oppositely charged ions are attracted to each other in all directions to form ionic bonds. Okay, so that bit there is exactly the same for each of these types of questions. The only thing that's going to change is what metal you've got and what non-metal you've got. Right, so ionic compounds have got high melting points. Complete the sentences using the word from the box. So calcium oxide has a giant ionic lattice in which there are strong electrostatic forces of attraction in all directions. Okay, now I'm going to do one more bit because I want you to see how it follows exactly the same pattern. Right, so this time they've given us a diagram, but they're asking us exactly the same thing. So we've got oxygen this time and calcium. So calcium is my metal, which is going to be positive. Oxygen is my non-metal, which is going to be negative. So describe how the calcium atom and the oxygen atom forms calcium oxide. Now, calcium is in group 2 and oxygen is in group 6. So this time, instead of 1 electron being involved, it's going to be 2. But it's exactly the same way of answering the question. So calcium loses 2 electrons to form 2+ ion. Oxygen gains 2 electrons to form 2- ion, right? And then the last bit is exactly the same. The oppositely charged ions are attracted to each other in all directions to form ionic bonds. Okay, so I haven't changed this sentence. I've written it 3 times for 3 different questions. Okay, so that is something that you need to learn.